Hello guys, I'm Andrew Sadara, and this time I'll be teaching you about DC motor starter. So here we're gonna cover various aspects and types of DC motor starters. So let's go step by step on how and why, and at the end we shall see the we shall have the general concept on the DC motor starter. Welcome. So first, let us see the necessity of a starter. Now, when a DC motor is connected into supply directly, it draws a very high current, which is more than the rated amount. Now, to understand this, we have to consider the equation below. Now, here, what we try to say is that a DC motor should be connected directly to the DC supply. That's fine, but the problem behind is that it normally draws a very high current, which is more than the rated value. Now here down there is an equation. This equation here, IA, that is armature current, is equal to V, that is voltage supply, minus back EMF over armature resistance. Now if at all you connect it direct, it normally draws a very high current, as I've said below. Now, and this is due to the reason that EB is normally equal to 0. That means if at all the value of EB is 0 and the voltage supplied is almost, let's say it is 250 over the armature resistance, which is normally 0.0 something, actually the armature current is high. And now for this, we normally need a starter to decrease, or rather to regulate this amount of current. Now, on a starting motor, induced EMF, that is back EMF or EB, in the DC armature is 0 due to 0 speed. You see? Now, from the equation of back EMF, that is K, then phi N, that is the speed. Now, if at all EB is equal to 0, our equation becomes IA is equal to V over R. Now, from equation number 3, we can conclude that the amount of current is inversely to armature resistance. Whenever the amount of current increases, results to the drastic effects on the motor. Now, such effects are as follows. Now, these are the effects. If at all the back EMF is 0 and the current is high, now these are the effects to the motor. The first effect is detrimental sparking at the commutator. Now, commutator is affected directly by this detrimental sparking. Detrimental sparking is nothing but those sparks which have effects, or rather the drastic effects, to the commutator. The other thing is damages of armature windings. Actually, the armature has got the windings. Now, in case the current is high, actually these windings get damaged. Now, the other part is damage of the rotating parts like commutator. Now you see, before there we say there will be the possibility of having the detrimental sparking. Now here also it affects the whole circulation, or rather the rotation of the commutator. Remember that commutator is one among the rotating parts. Also, brushes became of high torque and quick acceleration and large voltage dip at the supply. You see, now if at all the brushes became of high starting torque, actually there will be the quick acceleration and the low voltage dip at the supply. Now the voltage dip to the supply actually affects the motor direct. Now these are the sum of the effects. Now for these effects, or rather to overcome these effects, is where we come to see we need the starter. Now, to avoid such effects, the resistance is introduced in series with the armature during the starting period, which limits the starting current to safe value. Now the resistance we introduce, or rather the starter introduce the resistance, which normally starters are connected in series with the motor. Now with that connection, the starter introduces the resistance. That resistance will decrease the amount of current to the safe value. The resistance introduced acts out as the motor gains speed and develop back EMF, which regulates the speed. So starter introduces resistance and the resistance introduces back EMF, which regulates the speed of the motor. Now, small motors can start directly. Now we are speaking on the is huge motors, or rather the big motors. Now speaking of the small motors, these motors have high armature resistance, and they have the inertia of a small armature comes up to speed very quickly. Now for these two reasons, we do not need these starters for the small motors. But now, as a matter of fact, the small motors actually perform small operations. Now speaking on the general terms about the motors of large size is where we need the starter. Now let us see the purposes of starters. Now the starters are there to protect the motor against damages, you see, as we have seen before, from excessive current, also to protect the motor against short circuits. See, now the short circuits have the effects to the motor to protect the motor against the long-term overload. Remember, I said before, if at all there will be no starter, or rather no resistance, actually the motor will face the long-term overload. Now the overload to the motor have got drastic effects, as we have said before. Now the last but not the least is to provide the convenient manner to control the operating speed of the motor. You see, we have said the resistance introduced back EMF, which regulates the current to the safe value. Now this safe value is the one which is needed to control the operating speed in the convenient manner. Now after that, let's see various types of DC starters. Now we have three types, but these are two generals. There might be others, but these are the general ones. The first one, we have 4-point starter, we have 3-point starter, and we have 2-point starter. Now let's see one type after the other and how it operates. Here we have 3-point starter. You see, 3-point starter, features of these starters are like armature, field, and hence the name. So here in this 3-point starter, we have the features as explained below. We have line, we have armature, we have field, and now these three features provides the name of the starter. Now the terminals must be connected respectively to the supply as shown in this figure. Now here I will demonstrate the short video on how the current flows and the features. See, initially this starter is connected to contact brass with stud 1 to 5 or sometimes up to 10, it depends. And actually this is our line here, as you can see, which is connected to the positive terminal, and this is our armature here, as you can see, and the other thing here is our field, you see. Now these are the general things which brings the name to our motor. As you can see, we have line, we have field, and we have armature, and this is our handle which is connected to in contact with the brass with various resistance 1 to 5 up to run position. Now there are other features like overload release, you see, which comes direct to our stud right here. And now after coming to this stud, when the stud is connected, the current will flow to this spring, and this spring will come to this handle, as you can see there. Now coming from this handle is where the hold-on coil gets connected in series across the supply, where the starting resistance RS is connected in series with the armature. The given starting resistance by the armature is given by IA is equal to V over RA plus RS. Now this is the general direction on how the current flows to the field, then to the armature, then back to this contact brass stud, and then coming direct to this when it is connected, then comes back to the supply, and the current keeps on circulating in that way. So here I will demonstrate again, as I've said before, how do the current flow. Now when the stud is moved to number 1, so the current will flow to the handle, to the stud number 1, that is the resistance number 1, then it will come direct to this electromagnetic, then to the field. Again it will come direct to the armature. See this. Okay, this is the other way around on demonstrating that equation, that is V over RA plus armature the starting resistance. Now the hand will be moved from stud number 1 to stud number 5 up to run. Now these 1 to 5 are the resistance, which are the safe value. Now on reaching number 5, the resistance is all cut out. Now the current flows direct to the handle, then to the armature, and now the motor will be running to the safe value. See, this is how the motor will be run to the safe value, direct from the line, overload release to our handle to safe value. Now, as I've said earlier, 1 to 5, these are the resistance values which are introduced by this starter, and the one as the handle move from left to the right is where our resistance decrease. So this 5 means the maximum value of our resistance, the minimum value where the motor will be running in the safe manner. So this is how the current flows through our starter. Okay, I hope it is clear. Now, as a matter of fact, you can just keep on watching this animation video, the short animation video on how do the current flow. Now at the end we shall see the other features. Now to put to insist on these matters, I think we can go together again with these explanations, that when the motor is at rest, the start handle is kept at off position as we have seen earlier. Okay, and this is our hold on coil, we shall see later. Now the starting resistance is connected to contact brass stud 1 to 10 or 1 to 5, it depends. To start the motor, the handle is moved to the right, touching the first brass stud. The first brass stud is this one. Now as soon as the handle touches stud number 1, the shunt field and the hold on coil get connected in series across the supply, where the full starting resistance is connected in series with the armature. The starting current is given by this equation. Now in case of the power failure, this stud will move direct from number 5, or rather to safe run position, up to the end. Now let's see further clarifications. Now, due to full starting resistance in series with the armature, the starting current will be lesser, since the current flows in field with the armature windings. The motor starts rotating. Okay, that full starting resistance in series with the armature, current will be less. Now since current flows in the field and the armature winding, the motor will start rotating. Now after certain speed, the starter handle is moved to stud number 2, as we have seen earlier. The arm is further moved. The starting resistance is gradually cut out till when the arm reaches the running position, the resistance is all cut out. Now the field current flow through the holding coil produces a great force of attraction than the spring pull. There is a soft iron piece S attached to the arm, which in the on position is attracted and held by electromagnet E, energized by short shunt current. Now the holding coil is also called no voltage release. The magnet which I was speaking about is this one, and this is the spring connected to our handle. So this, as it gets it works on the principle of electromagnetic induction. So when it gets electrified, it attracts this handle and hold it to safe position. Now in case of power failure, is when this magnet here gets demagnetized, and so it releases the handle. Okay, the holding coil is also called no voltage release. Now let's see some protection devices in motor. Actually, sometimes there might be power failure which is not intended. Now for that, we have designed different protection device. The first device is no voltage release. It consists of electromagnet which is connected to the field circuit. The function of no voltage release are as follows. Electromagnet is this one here, which is connected in series to the fields. Okay, As you can see here, there is a connection here, this wire direct to the fields. Sorry. Now, the function of these are to hold the starter handle in on position when the motor is in normal position. And as I've seen before, when you move the stud from 1 to 5 up to run, that is safe value, this electromagnet will hold it in position. In case of power failure, the electromagnet gets demagnetized and the spiral spring balance brings the handle back to off position. This prevents the stationary armature from being put across the line again when the power supply restores. So that's what we saw below. That is what we saw earlier, that this, in case of power failure, get demagnetized and the spring will pull back the handle to off position, as we have seen earlier. Now, it normally prevents the stationary armature from being put across the line again when the power supply restores. Okay, that we are through with. Now, if the shunt field becomes open circuit accidentally, the shunt field, that is F, okay, which is connected in series to the electromagnet, the speed starts increasing. Now you see the problem here. If the shunt field becomes open circuited accidentally, the coil gets demagnetized and the starter handle becomes off position. Now in case the starter handle is not released, the speed will start increasing gradually with the flux decaying. Now this small decreasing flux will result to dangerously high speed, and at the same time the armature current for a given load torque increases and damage the armature if fuse or circuit breaker does not disconnected the motor from the supply. So sometimes this fuse, or rather the fuse, now they act as the resistance. Now if at all this does not disconnected the motor from the supply, actually it will damage the armature. So this is one among the protection devices. Another protection device is overload release. Remember I mentioned it earlier. This device protects the motor from taking overloads. Okay, see, the motor should take only that specified, or rather that rated amount. Now the overloads will bring the damage, or rather the effects, to the motor. Now this overload release, it consists of electromagnet, or L, that previous magnet. See, there are two magnets here. There is this one here and this one here. Okay, this is what we are speaking of overload release. Okay, now let's see how it works. Which is connected in a series with the armature circuit and thus energized by the current. Okay, it is connected in series with armature, as you can see here. Now when this is full connected, the current will flow this way direct to our resistance. Okay, 1 to 5, then up to the armature. Okay, this is the series connection we are speaking about. 1 2 3 4 5 this way, coming direct this way, and now this only when this is connected with the armature, it's connected to the supply. Okay, this wire here moves direct here to this magnet. Okay, let's keep going, guys. Now in case the armature current exceeds by the predetermined value, then the movable iron Mi is lifted and short circuit the terminals of the no voltage release. Thereby the coil gets demagnetized and the starter handle flies to off position. Thus the motor is protected from overload condition. Now let's see this movable iron field, which normally short circuit and makes this demagnetized. Is this one here. Sorry. Behind this magnet here, as you can see, guys, there is a movable iron. Okay, this one. This movable iron here, which is connected here. So it is the one to connect this circuit direct to the armature. Now, in case it moves, this electromagnet gets the electromagnet, this one here, gets demagnetized and so release the handle to off position, and now okay, as it moves back, and now the motor is protected from the overload conditions. So that is how this overload release works. Now take into consideration if the if the field circuit and the hold-on coil are in series with the motor speed. If the field circuit and the hold coil are in series, and if the motor speed has to be increased beyond the rated speed, the field current has to be reduced. Now, at certain values of reduced field current, the electromagnet pulls off the holding coil. Okay, the electromagnet pull off the holding coil decreases and becomes less than the spring force. In such case, the starter handle returns to off position and the motor stops. Now you see guys, in some cases this speed of the motor has to be increased beyond the rated value depending on the need. Now if at all it has to be increased, actually we have seen the overload release and this other protection device as no voltage release. Actually it short circuits and the handle moves to off position and the motor stop. Now this makes 3-point starter unsuitable for varying speed motors. See, some of the motors have got the varying speed, the speed variation. Okay, you need to vary there should be the variation between the speed. Now for this, the 3-point starter becomes not suitable for such operations. Now to overcome this is where we are going to see the 4-point starter, which is suitable for variation in speed. And for that point, let's move to 4-point starter. Okay, and this is the wiring diagram of the 4-point starter. Okay, as the name suggests, there are 4 terminals. There is line, okay, L1, this one here. In this short diagram, this wiring diagram, it is labeled as N. There is field and there is armature. Okay, and now with these 4 terminals, it's where we are speaking. It's where we get the name of 4-point starters, only by these 4 points. The construction and the working of this starter is similar to 3-point starter, except with the connections in the hold-on coil. So the difference here is how this hold-on coil is connected. Is connected to our starter. As we've seen earlier, with the 3-point starter, the connection here is short and simple, but here it's a bit complicated. We shall see. The hold-on coil is taken off by the shunt field circuit and is connected directly across the line through the protecting resistance R as shown in the diagram. Okay, hold-on coil is taken off the shunt field circuit. Okay, shunt field circuit, this one here. Okay, and is connected directly across the line through the protection resistance. You see, there is direct connection. Okay, so this field, direct connection, this one, and across the resistance. This is hold-on coil and it is in off position now. Now during the starting of the motor, when the motor starter arm touches stud number 1, this one here, on the line current divides into 3 parts. Okay, one part passes through the armature and series field. Let's see that line. Okay, when it is moved in stud number 1, current divides into 3 parts. One part of the current passes through armature resistance and series field. Okay, and series field. Okay, this one here, direct to armature. Okay, the second part passes through shunt field windings. This is the second part here. Okay, as you have seen, again here to field winding. The third part through no voltage release coil and protective resistance. This part here, no voltage release coil, and when this is connected, okay, so these are the three parts: 1, 2, 3. The first one through armature resistance, the second one through shunt field windings, the third part through no voltage release. Okay, in this arrangement, no voltage release coil circuit is independent of shunt field circuit. As you have seen here, it is independent, okay, and it is in parallel connection of the NVC and the field. Okay, there's no problem, which means the electromagnetic pull exerted by the no voltage release or hold-on coil will always be sufficient, okay, no matter how field rheostat is adjusted for variable speed motor. Now here we are speaking earlier about the suitability of this 4-point starter. Now here is the reason. Ever since no voltage release is connected independent to the field windings, there will be, okay, which means the electromagnetic pull exerted by the no voltage release or hold-on coil will always be sufficient. In 3-point, it is not sufficient. Here, it is sufficient ever since no voltage release is connected independently to the field winding. Now, if at all it is sufficient, no matter how the restart, or rather no matter how the speed variation is adjusted, the motor will keep on running to the safe value. Now, let's see the short animation. Okay, when the HC gets short circuited, or rather, okay, sorry, when the hold coil gets short circuited by OR, the current through R is limited by its own resistance, and the starting resistance, the other component of the 4-point starter are the same as in 3-point starter. So these are just the clarifications, the more clarifications on the 4-point starter. Okay, now let's see the short animation on how this current flow, or rather the motor works. Okay, this is connection. See, the current moves and the stud is moved to position number 1. Okay, and the 3 components, see, this is how current flows to the motor, again back to the supply. Okay, now each component, as I've been explaining, on stud number 2, the motor will start rotating slowly ever since the resistance will be decreased. Okay, now let's see as we move the stud to number 3. You see the speed of the motor increase ever since the resistance decrease, and from our previous equation we saw that I is inversely proportional to resistance. Now let's see as we move the handle to stud number 4, let's see how will it be like. Okay, the speed of the motor increase, see, the speed of the motor increase, and here is the wiring diagram on how the current flows. Okay, so here you are taking into consideration the resistance decrease, the current increase, the speed of the motor increase. Now R4, okay, the back EMF introduced is too small, then the motor speed is decreased, it is increased, sorry. Now let's see as we move the stud to position number 5, the speed of the motor actually increase to the safe value, and as you can see, the motor now runs in the safe operation. Now the protective device works the same as in 3-point starter, with the exception of what I've been explaining earlier, that of no voltage release with the speed variation. Okay, now this get electromagnified and the motor keep on running. Now in case there is overload conditions, this point here, OR, okay, sorry, this point here, OR, short circuit the current, and the stud move back to position number 1. Now let's see the last type of the starter, on this DC motor starter, and this is 2-point starter. In series motor starter, also a starting resistance is inserted in series with the armature. Okay, this 2-point starter is also called a series motor. For limiting the starting current to safe value, the motor is illustrated in the figure. Okay, the DC supply is switched on, the starter handle is moved to the right for the starting motor. Okay, we shall see how it works. As soon as the starter handle touches stud number 1, the series motor is connected with full starting resistance, and as the handle is brought to on position, cutting all full resistance by the series motor, cutting the full resistance, the series motor starts running at normal speed. The functioning of overload release, the protective devices like no voltage release and the overload release are similar as explained in 3-point starter. Now let's see how it works. When the switch is closed at starting, the rotating arm pointer A is not touching the resistance. Okay, so there's no supply, the motor is not running. Okay, so now when the handle is moved to tap number 1, the motor armature is connected to the reduced DC supply through the full resistance in service. Okay, now the motor starts running slowly. The handle is moved step by step, giving the small time interval between each tap change. Now this accordingly, the resistance gets reduced from the motor field windings. Okay, when the handle reaches the final tap position, it is locked magnetically in the final position through energization of the hold-on coil. The motor runs at normal speed. See, when there is any overload on the motor, the overload relay coil picks up. Hence, no contact close and short circuit the hold-on coil. So the hold-on coil loses its voltage supply and it drops. The resistance level is pulled back mechanically by the spring and it returns to its original position, stopping the motor. To stop the running motor manually, switch off the DPST switch. Thus, you have learnt about the starter and the DC series motor. Now, let's see the handling precautions. The starter handle, the first precaution, the starter handle should be slowly and smoothly moved from off position to on position for the safe starting of DC motor without sparks in between the studs within the starter. Okay, the DC motor should not be stopped by the moving starter handle from on to off position. If it is done, then the dangerous sparking is caused at stud number 1, because here the field circuit is broken and the stored magnetic field energy is dissipated from the heavy sparks. Okay, so these are the precautions you have to take into consideration. First, the starter should be slowly and smoothly moved without any spark. Now, in case it happens, there will be the dangerous sparking will be caused at stud number 1, because the stored magnetic field energy will be dissipated in the form of heavy sparks. See?